All right, gang, let's talk for a moment about 802.11g. All right, the 802.11g standard operates at the 2.4 gigahertz frequency. That means it's the same playing field as what we saw with 802.11b. But unlike 802.11b, it supports a maximum data rate of 54 megabits per second. Why? Because instead of using the encoding and modulation techniques of direct sequence spread spectrum, it uses orthogonal frequency division multiplexing. In other words, it's smarter and able to encode things in a more complex way to send more data in less space. It's less focused on ensuring reliability and more focused on sending data quickly. It is backwards compatible, though, with 802.11b because it operates at the same frequency range and can still run the DSS method if asked by a particular client. So in other words, we can have a particular client running G over here, and we can have a B client over here, and they can play nicely with each other through that access point. It'll support a maximum data rate of 11 megabits over here and a maximum data rate of 54 over here. In fact, what we end up seeing, gang, is when we look at the tools that are used with 802.11bg support, when I have an access point that will support both of these together. When using the 64 quadrature amplitude modulation form of communication, we can enable up to 54 megabits per second. Pretty sweet. And OFDM will support all of these methods all the way down to 12 megabits per second. But it can also support QPSK with CCK 128 to support the DSSS rate of 11 megabits per second. But we can go back to OFDM to support some intermediary rates of 6 and 9. Then for DSSS, we can support, again, 5.5, 2, and even 1 using the Barker encoding mechanism. So the final result here is essentially we see this continuum of what's supported to support either 802.11b clients using DSSS or 802.11g clients supporting OFDM.